Question number 21. Okay. A wire is fixed at one end and extended by a force F1 acting on the other end. Okay. So I have a wire. And now I am applying a force over here. I am applying a force over here. F1 here. Okay. This causes the wire to have an elastic potential energy of 0.15 joules. Because I have extended this, applied a force, this should have an extension. So therefore energy is 0.15 joules. Okay. The force applied to the wire is now changed to a force F2. Now what do? I apply a next larger force over here. This causes the wire to have a new elastic potential energy of 0.6 joules. It has a larger elastic potential energy, which is 0.6 joules over here. 0.6 joules. So the wire obeys Hooke's law. Okay, which means what? The force is proportional to displacement, or acceleration proportional to displacement, or Young's modulus is a constant. Okay, they even need not go. You can say Young's modulus is a constant. What is Young's modulus? Young's modulus is equal to stress by strain. Stress by strain over here. Okay, so now how is this Young's modulus or stress and strain related to the elastic potential energy? That's what we need to look at to derive the relationship between F1 and F2. Okay, now what we need to do? We know that work done in extending a string is given by half into stress into strain into volume. Okay, remember this formula, this volume, many people miss it. Okay, you will not miss it. Okay, so this should be half into stress into strain into volume. Okay, next, so what do I write here? Now what I do is, we know stress by strain equal to volume, or I don't need this strain. So what I will do is, I will from here I will write strain is equal to stress divided by y. Okay, so what I will do, I will write this as half into stress whole square, stress into, instead of this I'll write stress once again divided by y into volume. Okay, so now you have stress into stress. So what do you get? So half into stress whole square into volume divided by y. See, this volume of the wire remains a constant. By extending something, are you increasing the volume? You are not increasing the volume. Length increases, area decreases, right? That's where you study about Poisson's ratio. Why? Young's modulus, same material, doesn't change over here. He says it's a constant. It was Hooke's law. And then you have half. So therefore, this, what is this now? Work done is proportional to stress squared. What is stress? Stress here is nothing but, stress is equal to force divided by area. So stress is proportional to force. Okay, if that is the case, now work done is proportional to force square over here. Okay, making the area being negligibly changing over here. Okay, so therefore now what I do is, now I have two energies over here, elastic potential energies. I'll write W1 by W2 is equal to F1 by F2 the whole square, right? Now what is W1? W1 is 0.15. Let me write it down. 0.15 divided by W2 is 0.60 is equal to F1 divided by F2 the whole square. So 15 fours are, so this should be 1 by 4 is equal to F1 by F2 the whole square. This implies F1 by F2 is equal to 1 by 2. So we already have F1. Okay, we need F2 here. What is it required? Okay, let us first write down the equation. That will be easy for us to proceed further. I will now write F1 is equal to 2F2. Where is this equation? Do we have F1 equal to 2F2 here? F1 equal to 2F2. Answer is here. Okay.